Okay, so let me ask you something. What if you could know with like pinpoint accuracy exactly when something is about to break? Well, that's the whole promise of AI-powered predictive maintenance. And today, we're going to dive into how it's making that what if a reality. You know the feeling, right? We've all been there. The assembly line just stops. The office air conditioning gives up the ghost on the absolute hottest day of the year. Or your car decides, nope, I'm done. Unexpected failures are so much more than just a pain. They're chaotic, they're expensive, and they're just a massive headache for everyone involved. But imagine this. What if that machine could give you a super specific forecast? Not just some vague warning light, but a message that says, hey, just so you know, the engine's probably going to fail next Tuesday afternoon. That is the incredible power of AI-driven predictive maintenance. It's all about shifting from reacting to problems to actually getting ahead of them. And this slide just lays it out so perfectly. For decades, the philosophy was simple. If it ain't broke, don't fix it. You know? That's reactive maintenance. You wait for the breakdown, then you scramble like crazy to fix it, which, of course, leads to all that costly downtime and chaos. But the new way? It's a total game changer. The entire philosophy flips to fix it before it breaks. It's about using data to plan ahead and just avoid all that drama. So what's the magic behind this huge shift? Well, in a word, AI. Artificial intelligence is what lets us go from just guessing to actually knowing. It's completely transforming how we take care of the technology that, let's face it, runs our world. Now, it might sound really complex, but the basic idea is actually beautiful in its simplicity. We're essentially using AI to listen to all the tiny, subtle signals our machines are giving off all the time. Little changes in vibration, a slight increase in temperature, a dip in performance, and then interpret what those signals mean for the machine's overall health. To really get a handle on this, it helps to think of AI playing two really distinct roles here. I like to call them the doctor and the fortune teller. And each one answers a totally critical question. So, first up is the doctor. This is the diagnostic phase. The AI's first job is to basically run a checkup. It looks at a component and asks, is everything okay here? Is it healthy or is it, well, sick? This is what we call fault detection. And you can see here how this works in the real world. Research from Sharma, for instance, uses things like RNNs, which are just AI models that are really good at looking at data over time, to classify a part as simply failure or non-failure. But what's really cool is work like Zhang's, which uses explainable AI to understand the why behind a problem. You know, it's like a doctor who doesn't just tell you you're sick, but can tell you exactly what's causing it. Okay, so once the doctor makes the diagnosis, that's when the fortune teller takes over. This is where the AI model looks into the future. It forecasts what's called the remaining useful life, or RUL, of a part. It's literally predicting how much time it has left. And we're seeing some really advanced deep learning models being used for this. Things like LSTMs, which are great at understanding sequences, they're being used everywhere, from industrial parts to critical ship engines, and even for your office HVAC system. So yeah, this isn't some far-off sci-fi concept. It's happening right now. But wait a second. How does the AI get all this information? I mean, it can't just know this stuff, right? It needs eyes and ears. And that is where the data comes in, all thanks to a technology you've definitely heard of, the Internet of Things. Simply put, IoT is all about sticking tiny sensors into physical objects, everything from jet engines to city water pumps that are constantly collecting and streaming data online. These sensors are like the nervous system that feeds the AI brain. So the whole thing really boils down to a pretty straightforward three-step process. First, the IoT sensors gather just a ton of data. That's the fuel for the whole system. Second, the AI sifts through all that data, hunting for the tiny patterns that scream future failure. And third, the system gives you a clear, actionable insight. And this is already being used to manage city infrastructure, which is pretty amazing. And while you might think this is all just for giant factories, this technology is spreading into pretty much every corner of our lives, and in some really surprising ways. I mean, just look at this list. We are talking about keeping massive ship engines running smoothly in the middle of the ocean, predicting the battery life on a drone to make sure it can actually finish its mission, even analyzing lubricating oil to spot a gearbox problem before it happens. And get this, it's even being used in cybersecurity to predict when network firewalls might need maintenance to stop threats before they even become a problem. How cool is that? So where is all this headed? What's the next big leap? Well, it's all about making the AI smaller, faster, and way more independent. So welcome to the era of AI on the edge. The key here is a technology called TinyML, literally tiny machine learning. And it's all about shrinking these really powerful AI models down so they can run directly on tiny, low-power chips that live right inside the machine itself. No internet connection required. See, traditional AI has to send data all the way to the cloud and back for analysis, which takes time. Edge AI, using TinyML, does the analysis right there on the device. It's instant. And it works even if the internet goes down. Research on things like CNC machines shows how valuable this is. You get immediate, real-time alerts where every single millisecond counts. And that's exactly why this is such a huge deal. It really is a major advancement, embedding that intelligence directly into the tools and machines we count on every single day. So, to wrap this all up, if you remember just 3 things, make it these. First, AI is tackling that age-old problem of unexpected breakdowns by moving us from being reactive to being predictive. Second, it pulls this off by playing 2 roles: the doctor who finds the problem and the fortune teller who sees the future. And finally, the big trend is that this AI is getting smaller and faster, with TinyML putting that brain power right where the action is. It is an incredibly powerful concept, and it's already changing our world. And it kind of leaves us with one last fascinating thought, doesn't it? As AI gets better and better at predicting the failure of machines, what else could we use this incredible predictive power for? What will it predict for us next?